Okay, let's go back to September 3rd, 2017. All around the world, seismographs, the machines that detect earthquakes, started going crazy. They picked up this massive geological event, but it was in a place where an earthquake just shouldn't happen. And you know why? Because this wasn't an earthquake. It was something far more deliberate, and honestly, way more terrifying.
What those machines were feeling was North Korea detonating a nuclear bomb. And look, this wasn't just any bomb. The energy from this single test was estimated to be more than 10 times the power of the bomb that was dropped on Hiroshima. That is just a terrifying leap forward.
So, fast forward to today, and the best estimates say that North Korea has an arsenal of around 60 nuclear weapons ready to go. Now, think about that. Despite sanctions, despite blockades, with the entire world trying to stop them, they did it. So the big question, the one we're going to tackle is, how on earth did they pull this off?
Right, so the journey from this isolated, sanctioned state to a full-blown nuclear power, well, it's a story of some pretty terrifying ingenuity. And believe it or not, it all starts with something you'd probably just kick out of the way on your driveway thinking it was simple gravel.
No, I'm not kidding. It all begins with raw uranium ore mined from sites across the country. Workers take these completely ordinary-looking rocks, crush them into a fine powder, and then just dump them into these huge vats of sulfuric acid. After a whole chemical process, you're left with this:
a bright yellow powder called yellow cake. This stuff is about 80% uranium, and it's the starting block for the whole program. But here's the massive fundamental problem that North Korea and anyone else trying this runs into. This is the wrong kind of uranium to build a bomb.
So, to build a weapon, you have to solve this incredible scientific puzzle. It's kind of like trying to separate two identical twins, but with a catch. One of the twins is completely harmless, and the other one is catastrophically explosive.
You see, natural uranium is almost all U-238. It's the boring, stable older brother. It's basically a paperweight. It just sits there. But this tiny, tiny fraction, just 0.7%, is U-235. And this is the wild younger brother. If you hit this guy with a neutron, it splits apart and sets off this insane chain reaction. Basically atomic popcorn that can level a city.
So here's the bottom line. You have to get that 0.7% of the good stuff all the way up to over 90% to make a bomb. That is a monumental task. So North Korea, facing this insane challenge, decided, you know what? We're not going to pick one path. We're going to do both at the same time.
All right, path one is basically atomic witchcraft. Seriously, instead of trying to filter out that super rare U-235, they decided to just take the boring, plentiful U-238 and transform it into a completely new man-made element, plutonium. So inside their reactor at Yongbyon, they're just bombarding uranium fuel rods with neutrons. A U-238 atom gobbles one up, becomes unstable U-239. It then quickly decays, first into neptunium, then it decays again, and boom! You've just witnessed atomic alchemy. You now have plutonium-239, which is perfect for a bomb.
But, and this is a huge but, timing is everything. If you leave those fuel rods in the reactor for too long, that shiny new plutonium-239 starts catching neutrons itself, and it turns into plutonium-240. That's the unstable cousin that can make the bomb go off too early. They call it a fizzle, and for a weapons designer, it's the ultimate nightmare.
So once they pull the rods out at just the right moment, they have another insane job ahead of them: getting that tiny bit of plutonium out. This means chopping up these intensely radioactive rods and dissolving them in boiling nitric acid. Then, using a process called Purex, automated robots have to carefully pick out the precious plutonium from what is, literally, the world's most toxic soup.
Okay, now for the second path. This one isn't about some elegant alchemy. This is all about brute force engineering. This is the direct approach, trying to separate the wild U-235 twin from its boring U-238 brother using sheer unbelievable speed. First, they have to turn that yellow cake powder into a gas. Then, they pump that gas into thousands of centrifuges. Inside each one, a rotor is spinning at a mind-boggling 90,000 revolutions per minute. At that speed, physics itself starts to sort the atoms for you. Just to put 90,000 RPM into perspective for you, your car's engine probably redlines around 6,000 RPM. These machines are spinning 15 times faster than that. The heavier U-238 gas gets slung to the outside wall, while the slightly lighter, explosive U-235 gas tends to stay a little closer to the center.
But here's the catch. One single centrifuge barely makes a dent. It might increase the U-235 from 0.7% to like 0.72%.
So to get anywhere close to weapons grade, North Korea had to build and connect thousands of these things in a long chain, what they call a cascade, where each machine enriches the gas just a tiny bit more before passing it to the next one.
So through one of these two incredibly hard paths, they've done it. They have weapons-grade plutonium or highly enriched uranium. But, having the fuel is like having gunpowder without a gun. Now you have to actually build the bomb, and this is the part that truly keeps weapons designers up at night.
What they do is machine the fissile metal into a perfect sphere, the nuclear core. Then they wrap this sphere in a complex shell of conventional explosives, which are shaped into lenses to focus the blast inward. All of these explosives have to go off at the exact same instant to crush that core and trigger the nuclear chain reaction. And their margin for error? 1 microsecond.
Think about that. A microsecond is 1/1,000,000th of a second. That's the amount of time it takes light to travel just about 300 meters, or 3 football fields. If a single one of those detonators is late by even that tiny, infinitesimal amount of time, the whole implosion is lopsided. You don't get a mushroom cloud, you just get a very expensive, very radioactive mess.
So mastering this absolutely insane precision took them years of trial and, well, a lot of error. But eventually, they mastered it. And once they did, their test device stopped being a science project and became a credible global threat.
Just look at this timeline. Their first test back in 2006 was basically a fizzle, less than a kiloton. The world kind of laughed it off, but they were learning. By 2016, they were hitting Hiroshima-level yields, and then came that monster test in 2017, potentially 250 kilotons. That learning curve is just terrifyingly steep.
And of course, a bomb is totally useless if you can't get it to the target. Their Hwasong-15 missile can, in theory, hit anywhere in the continental US. But what's really scary is what they're doing with submarines. A sub can hide anywhere in the ocean, giving them what's called a second strike capability. It guarantees they can hit back, and that's what makes the threat real.
So there you have it. Through a combination of atomic alchemy and sheer brute force engineering, they went from worthless rocks to a working arsenal of around 60 nuclear weapons. They solved some of the hardest scientific and engineering problems on the planet, all while being sanctioned into isolation. Their success has totally changed the game, and it leaves all of us with one very chilling question. What comes next?